Hi. So what we're going to talk about today is special angles in radians. Okay? So a few things that I want us to remember. One is the two special triangles that we use. And remember the first one had two angles of 45 degrees, except now instead of thinking 45 degrees, we should think pi by 4, because that's the equivalent of 45 degrees. So we've got another pi by 4 there, and we remember the measurements on this triangle. It was 1 and 1, and then there was a root 2 there. And if you can't remember that, then just think Pythagorean theorem, right? Because that's all that root 2 is 1 squared plus 1 squared is equal to square root of 2 squared. Okay? Then we also have another triangle. And this triangle had 30 degrees and 60 degrees. Except now, instead of thinking 30 and 60, we should think pi by 6, because that's the equivalent of 30, and pi by 3, because that's the equivalent of 60. Now, if you have trouble remembering the measurements on this one, just think of it as an equilateral triangle that's got 2 on each side. So that makes the one side 2 and the bottom is 1 because it's only half of a side. And then we can forget the fact that it's an equilateral and use Pythagorean theorem again to figure out the fact that that last side there is root 3. Okay? So these are the two triangles that you have to remember. Okay? So it's the same as in grade 11, except now we're just thinking in radians. Alright? So 1, 1 root 2 and 1, 2 root 3. Those are the two triangle measurements. So let's look at some more review. On a unit circle, we can have an angle that we turn by, let's say theta, and that point on the unit circle is xy, and we know that that comes from the x measurement and the y measurement, right? So now based on this, we can figure out the trig ratios in this on that after that turn theta. We can use SOHCAHTOA from grade 10 and say that sine theta is opposite over hypotenuse, and we can label opposite, hypotenuse, and adjacent. So then sine theta becomes y over 1 because hypotenuse is 1 because it's a unit circle. So y. Cos theta then becomes x over 1 or x, and tan theta becomes y over x because it's opposite over adjacent. Okay? So those are some other things that we have to remember. Finally, for review, we also have on a unit circle turning by 90-degree angles, right? So if I turn by 90 degrees, that's pi by 2, right? Remember, because the whole half a turn is pi, so a quarter turn is pi by 2. And we have a point up there that's 0, 1. So, and we have a starting point that's at 1, 0. We also could do a half turn, which is pi. We also could do a 3/4 turn, which is 3 pi by 2. And we also could do a full turn, which is 2 pi. Okay? So let's figure out the ratios for these angles. So, sine pi by 2, well, the term pi by 2 is the red angle. So if I look at that ending point, y is equal to 1. And remember from the previous slide, sine theta is equal to y. So if y is equal to 1, then that means that sine pi by 2 is 1. On the other hand, cos 3 pi by 2, if I look at the green angle, cos is the x part, so cos 3 pi by 2 is going to be 0. Okay? So we just have to remember this unit circle and the rotations on the unit circle, and that'll help us remember the 90-degree increments. So sine 90, sine 180, sine 270, and same with cos. And now we're just going to think of it in radians. So sine pi by 2, sine pi, sine 3 pi by 2, and sine 2 pi, and same with cos, and same with tan. Okay? All right. Last thing I want you to remember is that we also have some other ratios. Secant x is 1 over cos. Cosecant x is 1 over sine, and cotan is 1 over tan. Okay? So let's do an example. Let's state all the primary trig ratios for the angle theta is 7 pi by 6. Okay, so 7 pi by 6. So there's my unit circle that I always want to start by drawing. And then we can think of pi by 6, 7 pi by 6. Remember that pi is 180. That's important. And we can also think of this as pi plus pi by 6. That'll give us 7 pi by 6. So when I draw my angle, there's pi, and then a little bit more, and that's my 7 pi by 6. And I've also known that the related acute angle is pi by 6, because that's the little acute angle, right? Or we can think of it as 30 degrees, but we don't have to, because we can now think in radians. So what we need to do is first figure out the three trig ratios for sine, cos, and tan for the related acute angle. Okay? And now, sine pi by 6, well, if we think back to that initial triangle here, sine by 6 is going to be opposite over hypotenuse. So that is 1 over 2. Right? So sine pi by 6 is 1 over 2. Looking at the same triangle, we can figure out that cos pi by 6 is root 3 over 2, and tan pi by 6 was 1 over root 3. Okay, so that all comes from that special triangle. Then we need to think, but wait a minute, 7 pi by 6 is in quadrant 3. And when we start thinking about different quadrants, we have to remember the cast rule, C-A-S-T. So that means in quadrant 3, tan is the positive one. So that means that sine 7 pi by 6 is negative a half, cos 7 pi by 6 is negative root 3 over 2, and tan 7 pi by 6 is 1 over root 3. And that's it. So this is the process that we have to go through when we want to figure out primary trig ratios for our special angles. And this first part here, you can either do that or you don't have to do that. It's up to you if you want to take that extra step. So that's only if you need it. Okay? But the red part, that's our final answer. Those are the primary trig ratios for 7 pi by 6.